All right. So I've been asked to do these. I'm told are the ones that really need to be done, demonstrated. So if we have parallel lines, which we have 3 parallel lines, and they're split by transversals, then these segments that are formed by the parallel lines will be proportional. So you can write this as 4x over 5x equals 4x plus 8 over 6x minus 10. And I will show you how to do the math even if you didn't simplify this, but we can actually reduce these fractions. We can cancel out the x from top and bottom, leaving us with just 4/5. And we could also cancel out we can divide top and bottom by 2 on the right. And if we divide everything by 2 here, divide this by 2, we get 2x plus 4. We divide this by 2, we get 3x minus 5. Let's see what we get when we do that. We get 2x plus 4 over 3x minus 5. And when we cross multiply, we say, okay, then we get 4 times 3x minus 5 equals 5 times 2x plus 4. We simplified the ratios. I hope you could see what we did there. We canceled the x on the left and we canceled a 2 on the right. And then when we multiply through, we get 12x minus 20 equals 10x plus 20. Okay, so I'm going to subtract 10x from both sides. And we get 2x minus 20 equals 20. And I'm going to just move this up. If we add 20 to both sides, and divide by 2, we get x equals 20. Seems okay to me. I don't see a problem with this solution. And I know that some of you had done this in class with me and would say, but wait a minute, didn't we have to multiply and then we got an x squared term and all of that? And you do, and you got that other solution that x equals 0. I'm trying to figure out a reason why we shouldn't be able to do this. And the only thing I can say is that if the x's got canceled out all the way around, we wouldn't be able to solve for them, but they only simplify on the left. They cancel on the left, but they're still on the right, and so they still appear there to give us what we get. It is true that there is a solution of 0 that we could get for x, but something funny happens there anyway, because let's just take it and put it down at the bottom here. If you said, okay, 4x over 5x equals, and let's see what we've got, 4x plus 8, 6x minus 10, 4x plus 8, and 6x minus 10. If x was 0, obviously this would turn this to 0, and this would turn this to 0, okay? And then over here we get 0 over 0 equals, that the zeros for x turns that to 0, and we'd get 8 over negative 10. And that's just a funny solution that doesn't seem to work. So obviously that doesn't work anyway. So I'm trying to figure out a reason why can't we do that and cancel the x up top from the 4x and the 5x, cancel it out to just be 4 and 5. And I don't know, if I come up with a reason why you can't do that, I'll let you know. But for now, it seems to me that seems like a fine thing to do. So I'm going to see if we can try that on the other side and see if there's any problem with that, okay? Because watch what happens when we get this proportion here on this side. We can get 12 over 7x equals 2x plus 2 over 5x minus 1. And in this case, nothing is going to cancel out, actually. There's no common thing that you can cancel out on this side. On the right-hand side, there's no common multiple that we can cancel. On this side, there's no x or any common multiple for the coefficients or the constants. So let's just multiply. So diagonally, we get 12 parentheses 5x minus 1. What I'm doing there is I'm multiplying that by that equals 7x 2x plus 2. And that, of course, is the other diagonals multiplied. Okay? So when we simplify, we get, we get 60x minus 12 equals, and we multiply the 7x times 2x, we get 14. X times x is x squared. So we have an x squared term in this one. And then 7x times 2 is 14x. And now we're going to move everything to one side so that we can, and let me move this kind of up like this so you can see it better, so that we can set it equal to 0, because that's how we're going to be able to solve for this. You'll get more comfortable at that and the reasons why it has to be equal to 0 as we keep doing it, but I'll talk about it here in a minute. 14x squared minus 46x. And then I'm not done moving everything to one side, so I say plus 12, 0 equals 14x squared minus 46x plus 12. And I'm just going to show you something. I'm just going to show you something that's allowed to be done to simplify things for you. Notice that everything on the right-hand side, all three terms, this 14x squared, this negative 46x, and this positive 12, they're all even numbers, meaning you can divide them all by 2. What does that look like when you divide them by 2? Well, dividing 0 by 2 still gives you 0. And dividing all of these things by 2, you end up with 0 equals 7x squared minus 23x plus 6. Okay? And now we're trying to factor this. I've worked with you on this before over the last week, but we're going to factor this. We're going to say it's still equal to 0, but what we're going to do is we're going to break this into two pieces. Now this one's a little bit more challenging because there's a 7 in front, but that's much easier than the 14 that was in front before we divided everything by 2. So you've definitely made this easier for you. Why particularly is it easier for you? Because 7 only breaks down one way, 7 times 1. So I could say 7x here and x here. It doesn't matter where each of them land. X could be in front and 7x. But it's only 7x and 1x. That's the only way you can break up 7 is 1 times 7. So now what do we have to do? We should take that 6 that's over on the side. I'm sorry, when I say over on the side, what I mean is right here at the end. This is the constant. And let me stop here and say, if you don't know what a constant is, you should be coming and talking to me. There is no one at this point that should misunderstand what a constant is. So if you don't understand what it is, come to me and you can sit with me for an hour if you want to. I still don't get it. Still don't get it. I still don't get it until you get it, because you need to get it. It shouldn't take you an hour, but you should be clear on that. So in this, let me box this out. Well, I'll just do it with my laser pointer. This right here, there is only one constant term on the right. This is not a constant term, it's a variable term. This is a variable term. They're different variable terms, unlike terms, and you can't put them together. But this is a constant. There is no variable attached to it. It is just worth 6. So we're going to take that constant that's at the end, and we're going to break it apart into 1 times 6, 2 times 3, increasing by 1 every time on the left, 3 times 2, And we can't do 4, we can't do 5, we go all up to 6. Why do I write these pairs twice in opposite order? Because what I'm going to do is we're going to plop them in here in a second. But the first thing we're going to do is we're going to say, what do the signs need to be? What do these signs need to be? Like, in other words, here, should I say plus or minus? Here, should I say plus or minus? How do I know? How would you know how to do that? Well, conceptually now, this is where the understanding the concept comes in. This number here at the end, 6, it's a positive number. And where does that come from? That comes from multiplying this, the number that's going to be at the end here of this binomial, by this number that's at the end of the binomial. And we're trying to figure out what we should put there to make it true. But this times this is going to give you the 6. That's where that 6 is going to come from if you were to put it back together. So how do you get a positive number? It must have either been a positive times a positive or a negative times a negative. So we know that when this number here is positive, we have the same sign twice. And that makes it easy because we just need to figure out what's the sign. So now what you do, you look at the middle term. What's the sign of the middle term? It's negative. That means they're both negative. Okay? And notice this. They're both negative, and even though there was in the original trinomial, there was a negative and a positive, what this says, there's one of each, isn't what determines what this is, okay? This being one of each is not, you don't say, oh, then there must be one of each down here. That's not what's going on there, and don't be naive about that, okay? Now, what we're trying to do is we're trying to take what's over here, and we're going to plop these numbers in. I'm going to do it in a different color so you can see it. Let's say that green that I love so much, apparently. And I'm going to plop in the 1 here and the 6 here to test them out. And then we're going to FOIL them, and we're going to say, what do we get? So let's FOIL these. When we do that, we say, okay, FOIL is first, obviously, is this that times this times that. That gets us the 7x squared. Okay, but this times this gives you the 7x squared. We're not worried about that. What we're worried about is where did this middle term come from? And did we place it right to get that middle term? So if we were to FOIL by saying this times this, we would end up with outer and inner of. Outer would give us 7x times negative 6, negative 42x. And inner, negative 1 times x, negative 1x, or minus x. That turns into negative 43x. That's no good. That's not what we want. You can see that we want to get negative 23x. So these green numbers, negative 1 and negative 6, that's not what's supposed to be there. So let's get those out of there. And let's try the next. So it's not that set. So let's try the next two numbers, 2 and 3. Put a 2 there, put a 3 there, and let's FOIL them. Or let's do the outer and the inner. The outer, 7x times negative 3, and you get negative 21x. And then the inner, negative 2 times x is negative 2x. And when you do negative 21x minus negative 3x, just like we wanted, because that's what you see in the original trinomial. So those green ones then are placed correctly. We do have the right numbers where we want them. Okay, so take that out of there, and I'll just write that better, that 2 again, that got erased there. Okay, so now we've got, and I'm going to write what was in green. I'm going to permanentize it. That's not how you say that, but by writing it in the proper colors that we had used. So negative 2 and negative 3. Okay, now here's this last big bit of it for finding out what the x's should be. The question is, how did we get 0? If we multiplied this binomial term by this binomial term, how did we end up with a 0? What kind of multiplication problems give you 0? What times what? Well, anything times 0 gives you 0. So we know that in order for it to become 0 there, we need to figure out what value of x turns one of those to 0. So we can say, okay, what if 7x minus 2 was the thing that was equal to 0, and then multiplied and made the thing 0 by adding 2 to both sides, and then dividing by 7, and we get x is equal to 2/7. That's one solution. Or maybe it was this term that turned the whole thing to 0. There's a value of x for this that would make that 0. And that value is x equals 3. So these two numbers are the solution to the system, or to the proportion. And is there any reason why they can't be the numbers that they are? Okay. Well, I would tell you the only way that they could not be the numbers that they are is if, for example, up here, you plugged in 2/7, let's say, for this, or for this, well, where the 2 is, right? You plugged in 2/7. I'm sorry, where the x is. You plugged in 2/7, and it worked out to be a negative number or 0, because you can't have 0 length or negative length. But negative, you don't get negative numbers when you put in 2/7. You also don't get negative numbers when you put in the 3 that we got down here. So both of those are solutions that would set the proportion to be true. So in the end, I guess I'll just leave it so you can see it like that. That's all the work. That's how you solve it. You really should go through and you should look at what I did there and watch the video again if you need to. I know it's kind of a long video, but these are apparently the two problems that gave everybody trouble. So good luck. I'll work with you again if you need it on this.